We are from Philippine Science High School main campus, currently grade 8 ilang-ilang.
Our group is composed of Nathan Garcia, Carl Roque, Aiden Bonachita, Anna Gagozum, and Nico Ogmani.
This video wants to help students when tackling radicals.
First, let us define what a radical is. As you can see here, this is how a radical is presented. It can be read as the nth root of A is B. Now let us discuss the parts of a radical. Here, n is the index. The radicon is A, and A is inside this sign, which is also known as the radical sign. B is the answer to this when it is solved.
There is no number written in the index part of the radical, then it is understood that the index is 2, and for this case it is read as square root, and therefore it is read as square root of 2. We also have numbers with bigger indices, such as the fourth root of 9, and we even have numbers or fractions outside the radical, and some of these are 5 over 2, root of 4, and also 2 root of 3 as seen here.
For any positive real number n and real numbers a and b, if b raised to n is equal to a, then a is the nth power of b.
Here are some examples to demonstrate the theorem. If 2 squared is equal to 4, then 2 is a square root of 4. Another example is 3 cubed. Since 3 cubed is equal to 27, then the cube root of 27 is 3.
So here are some essentials when we are simplifying radicals. First, if n is even, then a is positive, then the principal n fruit of the radical n fruit of a is positive. For example, square root of 4. If n is even, then a is negative, then the principal n fruit of the radical n fruit of a is imaginary. For example, square root of negative 4. It's not possible. Third, if n is odd, a is positive, then the principal n fruit of the radical n fruit of a is positive. For example, root of 4. Fourth, if n is odd, a is negative, then the principal root of the radical n fruit of a is negative. For example, cube root of negative 4.
Now, we will tell you the steps on how to simplify radicals. So, in order to simplify radicals, one must do the following. Step 1. Factor out the radical. Step 2. Group together the factors that are the same. Step 3. After regrouping, write the factors in exponent form. Step 4. See if there are any exponents in the radical that are greater than or equal to the index. Step 5a. So, you take these numbers with the exponents out. Whatever the quotient of the index and exponents would be the exponents of the factors outside the radical. Simplify if needed. Whatever the remainder from the quotient is, shall be the exponent of the particular factor inside the radical. And for the last step, if there are no exponents that are divisible by the index, leave the radical as it is. The first step we will do is to factor out the radical. So, in our example here, we will try to find the factors of 8. I like to use the method called the tree method to find out the factors of your radical. So, first we will draw a tree trunk and place your radicon in the middle. Now, we need to find out what the lowest factor of 8 is that is not 1, because 1 is neither prime nor composite. So, it is 2. Now, 8 divided by 2 is 4, which is the other because 2 is the lowest factor of 4 that is not equal to 1. Now, what is multiplied to 2 to gain 4? It is 2. Or you can simply divide 4 by 2. And you also get 2 again. So now everything is divided into the lowest possible factor that is not equal to 1. Now get these numbers, which are the outer branches, as I call it, and these will be equal to the factors of the radical. Now, you have 3 number 2s. It will be written as the square root of 2 times 2 times 2. And that is how you factor out the radical.
The next step is grouping the identical factors inside the radical sign. In this case, the 3 2's which are identical shall be grouped together. After grouping all of the factors, we will then convert the group factors into exponent form. So after converting, we will arrive with 2 cubed.
As the procedure states, now take out the numbers with exponents. So we know that 2 is raised to 3. So we shall take this out. Now we get the quotient of the exponent of the radical and the so take out the 3 divided by 2 is 1 remaining by 1. Therefore, the quotient itself shall be the exponent of the number outside. So then the remainder shall be the exponent of the particular factor that is left in the radical. It's 2 base 2. Therefore, square root is 2 square root.
On to our next example for today. Now, we will see what happens when there is a number outside of the radical sign. Our example today is 2 square root of 60. First step, factor out the radical. With prime factorization, you can get the answer 2 square root of 2 times 2 times 3 times 5. Now, next step is to find the like factors. In our case, you can see that there are 2 number 2s. So we group them together. This 2 times 2 is also equal to 2 squared. And then we copy the rest of the Now, next step, we check if the exponent of this number is greater than or equal to the index. Now, assuming that 2 is the index here, nothing is indicated, we can go and divide it. So first we get the exponent, which is 2. Then the index, which we can assume is 2, divided. We will come to the answer of 1 with no remainder. So 1, 0. Now, next step. Now, we take this out of the radical sign. So we will be moving it out. Then, this number will be out of the radical sign. And this number as an exponent. So, 2 raised to 1. Next step is to just copy the rest. So, this 2 will be here. I'll use different colors here. So, times 2. Then you copy the rest of the version here. So, square root of 3 times 5. Now, we just simplify and you will get 4 square root of 15. We got this answer because 2 raised to the first power is just equal to 2 times 2, so it will be equal to 4. As for here, you copy the radical sign, multiply 3 and 5, and you will get 15. So our final answer will now be 4 square root of 15, which is the simplified version of 2 square root of 6.
Speed things up a bit. Let's completely factor these three numbers. Let's start with 144. We know that 144 is 2 times 2 times 2 times 2 times 3 times 3. The next step would be to group the identical factors. So, we should group, that's right, the 2's and the 3's. After grouping the factors, we should then convert them to exponent form. What is the exponent form of 2 times 2 times 2 times 2? That's right, it's 2 to the 4th. Now what's the exponent form of 3 times 3? That's right, 3 squared. So now we have arrived with the factored form of 144. Let's move on to the next number, 100. We know that 100 is 2 times 2 times 5 times 5. Like what we did before, we would then group the identical factors. So the identical factors are 2 and 5. Then we convert them to exponent form. What's the exponent form of 2 times 2? It's 2 squared. Now what's the exponent form of 5 times 5? It's 5 squared. So now we have arrived to the factored form of 100. Let's move on to 80. We know that 80 is 2 times 2 times 2 times 2 times 5. Now we group the identical factors. The identical factors are 2, 5. What's the exponent form of 2 times 2 times 2 times 2? We know it's 2 to the 4th. Now what's the exponent form of 5? It's 5 to the 1, or simply 5. So now we have arrived with the factored form of the final number 80.
Now, let's move to another example. We have 9 cube root of 27. Now, as we see, we have an index greater than 2. And we also have a number outside. But it's just simple. Now, since you know how to factor completely faster, let's just factor 27 out completely. So it is equal to 9 times 9 to the 3 times 3 times 3 times 3. I'll group this together. And this becomes 9 to the root of 3. So now we divide the exponent inside by the number outside since it is greater than or equal to the index. So it is divided by the remainder 0. So it is essentially 9 times 3. And there's no number left inside since we have a remainder 0. So it's equal to 26. Okay. So let's say all the words we want.
Okay.
So thank you for listening to us once again. Carlo, okay? Instructor.
Anne Gogozum, another instructor.
Aidan Punachita, another instructor.
Mika Bumaki.
She's the camera
Woman who
Alright.
saved all our cameras and kept calling over and over again.
And here's
Matt.
who will
Edit.
compile the video for us.
Yes, and put
CGI.
CGI.
So, okay, taken
Wait.
on the day of April 21,
April 20 and
2016.
it's your last day of Ferio today.
video, this is the last.
I'll show you more exercises then.
Wow.
So, yeah, it's on your own, depends on you on how to
If you like more videos, visit our website.
Sige, go. If you want more.
Visit our website. Visit our website.
www.com.
Okay, there. That's a good name. So here's now that you know radicals, simplify radicals, you can even extend it into
Oh, we're all done.
conducting operations with it, like addition, subtraction, and then so now explore the world of
Radicals are
math
very
and
fun.
good luck.
Math
Maraming
is
salamat
fun.
po.
Thank
If you
you
think
po.
you've learned enough, no, you're wrong.
Okay, that's enough.